This is section 2. We're going to talk about arithmetic series this time. So not sequences, but series. Okay, you may want to make the correction right up here as I did. We're talking about arithmetic series. Basically, so we had this sequence last time that looked like this with numbers, and it could be like this. This was the sequence. The series is if you take each of those terms and instead of a comma we put an addition. So basically it's the value when they're all added up. So basically we just take them, we add them all together. That's what we, and what we get when we do so is we get a sum. Okay, a sum will also be used in this terminology. And then an arithmetic series is basically where arithmetic in this terms means we're going and we're adding a certain value, that common difference. So here it's positive 1. So an arithmetic series is where we have something that looks like this. It's a series, it's addition, which is a big difference, and then it also has a common difference between each individual term. Those are the building blocks. We're going to be dealing with series today where we're adding up all of the terms. This brings us to a key concept. It says the sum, which is represented by S sub n, that's the same thing as saying the sum of the first n terms. So here we're not saying how many terms. N is your number of terms in the series, and it's given by this. Okay, so we're going to use this formula a lot, and basically what it says is the sum is equal to the number of terms divided by 2, and we're going to multiply that by a sum over here of the final term plus the initial. Okay, so we're going to use that formula a lot in the next couple of examples. Okay, example 1. We're going to find the sum of the first 100 positive integers. So here's the series. You know that the first and last, you can see that the first number is 1. It's a series because it's addition. We have a common difference here. The common difference is 1 because we're going from 1 to 2 is 1, 2 to 3 is 1. We're adding 1 each time. The final term, which is a to the 100th, is 100 in this case, and that's shown by here. So now we can use the sum formula to help us find, instead of trying to attempt to add each and every single one of these together, the sum formula is our shortcut. So we want the sum of the first 100, so n is 100. It didn't list it up here, but I think that that's also helpful to know. So we have 100 over 2. A sub 1 was our first number, which was 1. Our a sub 100, which is going to ultimately be 100. So now we're going to simplify some things. We have 50 times, and it's 1 plus a to the 100th, or a sub 100 was 100. So now if we're finding the sum of the first 100 numbers, it's 50 times 101, which is 5,050. Okay, so we're basically what we're doing is we're defining certain values and then we're plugging them into the formula to find this sum of the first 100 digits, or the first 100 positive integers. I want you to do this one on your own. It's a little different, but it uses a lot of the same ideas. So I want you to go ahead and pause, complete this one, and resume when you're ready. So in explaining this, I wrote out the first grouping, and I actually counted up and I found that the 20th positive even integer was 40. So we can say the first number is a to the first, which is 2. In this, we're looking for if we added up the first 20, so we know that there's 20 positions. So the sum of n being 20 sub s sub 20 equals, then we have 20 over 2. Our first number was 2, and our last number was 40. So we sub them in and we do a little computation and we get our final answer to be 420. So big key things here. Find out what n is. Okay, n is your number of positions. If it's looking for the first 20 of them, then we got to say that we're looking at 20 different positions that we're going to be adding together, and that's crucial. The rest of it becomes very easy once you find that and once you find the 40 being the 20th integer. All right, the next example, it says a radio station is giving away a total of $124,000 in August. If they increase the amount given away each day by $100, how much should they give away the first day? So by that information, we're trying to find what a sub 1 was. In this problem, I'm going to introduce a new formula that you can also use for the summation. What this formula looks like is this. It looks very similar to the previous summation. There's just a few minor changes here. Notice it uses the common difference here, and when it says it's giving away $100 each day, and they're increasing it by 100, that's going to be our common difference. Okay, so this is one formula that you will need to know. And anytime that you see a common difference and that plays a big role in it, that's when you should use this formula. So a couple of other things to keep in mind here. We have a total amount of money, which is going to be S sub n at the end of the day. So we can go ahead and plug that in. It's going to be 124,000. That's going to equal, now what is n? Okay, we know that we're looking for a sub 1. Now we want to know what n is. So n is the number of days here, 31, because it's going to increase each day. So the first day it's going to have a certain amount, then it's going to increase by 100. That amount's going to increase by 100 again, and you're going to continue that until you have 31 days, because there's 31 days in August. So we have 31 over 2, and then within this big parenthesis, we can make it even a bracket if we'd like. We have 2 times a sub 1, which is what we're going to end up solving for, plus 31 minus 1 times that common difference. And now we just have to do some simplifying. So we get 15.5 here. It's 2 times a sub 1 plus 30 times 100. And that equals 124,000. Okay, I'm going to go ahead and divide both sides by 15.5 just to get rid of that piece. And when I do, I get 8,000 on the left side. These two go away. I have 2a sub 1 plus 3,000. I subtract 3,000. I get 5,000 equals 2 times a sub 1. And then I divide both sides by 2, and I get 2,500 equals a sub 1. So again, a lot of this is algebraic. You have to just plug in your values and then solve it out. We would want to put a dollar sign here and say this is $2,500 is what they should start with. And if they're going to give away $100 each day additional, so it starts with day 1, they start with 2,500. Day 2 would be 2,600, 2,700, and so on and so forth. Okay, I want you to use what we did on that last example to complete this example. So go ahead and hit pause and resume when you're ready to resume. Okay, again, March has 31 days. He did a total of 1085, so the sum at the end of 31 days was 1,085. We're looking for how many he started with. We don't quite know. And then the other thing we need to know is the common difference. He increased it by 1. So common difference of 1, it's not going to change a lot in here. So I plug this in. 31 over 2 times a plus n was 31 minus 1, which is 30, times d, which is 1. I'm going to skip a lot of this stuff. I know that 31 divided by 2 is 15.5, so I'm going to go ahead and do that division. Because I did essentially all of these operations on the previous problem, I don't want to spend a lot of time on them now. But basically we're solving it out. And we get that he started with 20 push-ups on the first day. That's a lot of push-ups. This is going to be our first class example, so I do want you to save this example, and you will not have to do the practice problem associated with this one. and I'll tell you which one that is in class. Thank you.